So, hello everyone and welcome back to another quick video, I would say. This is just me on my desktop on my main system, so for once you're going to see that one. So, I've talked a bit about in the past how my 2080 Ti does not have the best core and it can run 2085 MHz max, and then when it actually is under load it goes down to 2070 or 2055. Now, what you see right before you is not 2085. And in fact, that is not even the best thing. If we look at the statistics here, at the beginning when the card is cold, it boosts as high as 2145 and then 2030 and then 2115, which it pretty much holds all the time. Like, I tested this overclock a bit. I did this overclock yesterday. I played some games with it, and so far it's completely stable. So how the F did I do this? Because, like, I'm not a beginner in overclocking, especially when it comes to graphics cards. How did I get extra performance out of my 2080 Ti? And this not only goes for 2080 Ti's, this goes for pretty much every 20 series. It should also work on 10 series and also on 30 series, though I have not confirmed it for 10 and 30 series, but it should be the same thing. So what I did here, the only there's another thing that should catch your eye a bit, and that's the voltage. This card is running at 1.093 millivolts all the time, so pretty close to 1.1 volts. And that's not the voltage you usually see. Usually the card goes to 1.05 volts. And that's max. GPU boost, at least on my card, and pretty much every other card I've seen, doesn't go higher than 1.05 volts. And that voltage slider right here, I've set this in the GPU overclocking video, that doesn't do anything. Like, it says plus 100, but that doesn't mean plus 100 millivolts, it just means, because it says percentage here, GPU boost will hold the max voltage 100% longer. And that means that 1.05 volts. This is not what is getting me this higher voltage. What I'm doing here is something that I've seen on the EVGA forums. And originally I just wanted to lock a power state on the voltage frequency curve, but then I found out you can kind of abuse this system to get your card to a higher power state. Now I'm gonna say this higher voltage, GPU boost doesn't go to it. That doesn't mean it's out of spec. This voltage is technically allowed, and if the card was running at like 5 degrees or something, it would probably go to this voltage. It just won't in normal use when the card is not at 5 degrees. So don't get any panic that you're overvolting your card here and it's gonna die or something. No, this voltage is allowed, which is why I can't go higher. Like, I would happily go to 1.2 volts on this thing, but I can't. 1.093 is the max I can get, and the post I've read says that 1080 Ti's also have this exact same max voltage. Now, this is the mod, basically. This is the voltage frequency curve. You get to this by clicking this little icon right here. That's why it also says curve and not offset. And yeah, I've kind of explained what the curve does in the GPU overclocking video, but right here I'm going to do something that I haven't explained. So, what you can see here, so the white line is an overclock offset that was applied before I enabled the curve. And then the grayish, the thinner line is the stock curve. And you see, right around here, the stock curve kind of does a weird thing that it shouldn't do. That's the thing that gives me the higher power state, because usually, you can see down here, 1.005 volts, 1.05 volts, that is the power state the card would normally sit at, and you can see it's 2085 MHz, which is the old max that my card had. Right now, it's sitting at this power state, which is the 1.093 volts, and 2145 megahertz at idle, which when you put it under load is 2115, just like this one under load. Oops. Yeah, now I messed it up. That. Yeah, which means 2085. Usually under load this went down to 2070, 2055. Just like this one goes down to 2130, 2115 under load. So, how do you do this? Well, let's first reset everything. And let me show you. So, first thing, max voltage, max power, max temperature, fan speed, set whatever you want. My card is water cooled, so I'm not gonna touch it. And you can set your memory offset. That doesn't have anything to do with it. I know that my card can just max it, so yeah, can apply that. And then you set an offset, which plus 89, or technically plus 75 is the same thing because it goes in 15 megahertz steps, and plus 89 is the last thing you can dial in before it goes to a higher step. It is the same step that plus 75 gives you. So then once that's applied, we go into the voltage frequency curve, and we go to the highest power state that our card will allow, which again is this 1.093 volts. If you don't know this, I guess you're gonna have to try and error. It actually also works if you do this with a higher power state, but ideally you wanna select the one that is the max power state. So this one right here, the 1.093 volt one. So what you're gonna do is hit CTRL+L. So this makes the yellow line appear, and this locks in this power state. And if you hit apply, you see a gray line appear. And that's the line that the card is actually at. And you can see right now I'm actually above 1.05 volts because the card is in idle. If I go under load, this would go to 1.05 volts and lower pretty much immediately. So what we're going to do is we select the power state that the card is currently running, and we're going to hit down arrow on the keyboard until it says -1. Then press enter, apply. Did you see what happened? It went back to the same clock, but now the stock curve has the spike in it. And we see the card went to the next highest power state. So we do this again. -1, apply. Whoops. Now we are at 1.075 volts. And the card went to a higher power state again, which actually is the next clock step right here. You can see those are ones below where 2075. This one is 2085. So let's do this again. Set it to -1. Enter. Apply. Higher power state. We do this again. -1. Enter. Apply. Again, higher power state. And now we do this one last time before we reach our max voltage. -1. Enter. Apply. And now we have the max power state that we wanted. And you can see now we are at 1.093 volts, and the card will hold this voltage. It will not go away from this voltage or this clock unless it gets super high or hits the power, unless the temperature goes too high or it hits the power limit. But it will hold this voltage. That's what the CTRL+L thing with the yellow line does. It locks in this power state. And the thing we did with the -1 thing is enable this power state, because usually GPU boost doesn't go that high. But by doing this, you force GPU boost to go this high. And now the card is eternally set to this voltage and this frequency. And now you can theoretically dial in a higher offset, because what we just did is give it more voltage. And more voltage usually means it can now run faster. Now this is a 0.043 volt, 0.043 volt difference, which is not a lot. It's very little actually. But I can actually tell you that I actually wasn't sure what the offset is. It was either +129 or +139. I think it was +1. No, actually it shows. Yeah, I don't know. It probably is a bit different from the plus 89 and plus 75 offset now. But this is above 2130, so technically this is within the 2145 boost step. So, and you can see, this is actually above. This is 2130. This is above 2130. So above 2130 means next boost step, which is 2145. This is actually above the maximum of the curve at like 1.25 volts, which is where it ends. So the curve is very conservative in the higher voltage range, but, well, whatever there is doesn't really matter because no Pascal, Turing, or Ampere card will go that high. So, and you may ask what happens when we also set this to -1, because like we had our max voltage, and you can find out what's your max voltage if you just go further. If you do it again, you'll go back to your stock voltage. So this is pretty much the voltage that I usually get. It's not under load right now. Like, the voltage is kind of weird. It goes down under load, but it can also go up under load. It's kind of weird. Usually it's probably not at 1.05 because the locked in thing doesn't work. But usually it's 1.05 and it goes down from there when it's under load. This might be a bit lower either because our lock-in thing doesn't work at the moment, or because yeah, it might just be not under load and GPU boost is telling it, well, we can save some power. Yeah, so that's how you find out your voltage. The moment it goes back, you know, okay, this is the maximum boost step, so you just reset, do it again, which I've just showed to you. And yeah, so this is, yeah, it's a plus 129, but, oh wait, 2130? It just said 2145. Is this the right offset? Oh, I actually don't know. Oh, this is a normal offset. This is, yeah, okay, I don't know. You saw it said 2145 before. I don't really quite know. Yeah. But yeah, this is a pretty nice trick. And you can see my card actually picked up a lot of speed. So like, I wouldn't, okay, like 2085 was the peak before. Now the peak is 2145. And when actually running things, gaming on it or doing anything, it puts the card under load. Before it was 2070, 2055, now it is 2130, 2115. So the 2070, 2055 number before was technically within the standard overclock range. Like Gamers Nexus once said that on Turing they see cards hit 2050 to 2100 megahertz, and my card is technically within that. But the thing is, my card is, the error is extreme. It is a custom PCB with an upgraded, like, yes, it has more power stages, it has better output filtering. It technically even has a better VRM layout with 8 phases on each side and not like more phases on one side than the other. And it's also water cooled. So having within standard overclocking range is pretty disappointing for a card like that under these conditions. So that's why I always said the card is pretty bad. The core, at least. The memory can literally max the slider. Which is actually, I've only seen 2 other cards max the slider with plus 1500, which is pretty nice. But yeah, by doing this trick, my core can now run above 2100 megahertz, which is outside the standard range, and that for pretty much ever. It might do that because my card has a 366 watt power limit, which is really, really high. I think it is the second highest next to the Kingpin, which does have 2000 when you have the XOC BIOS. So it's a pretty high power limit, but I'm nowhere near maxing that out, so it shouldn't be too much of an issue. But yeah, this trick, which, I mean, technically it abuses the boost curve, but it is still within Nvidia spec. This voltage is allowed with, like, the card wouldn't go to it if Nvidia wouldn't allow it. because the only way to get actual without outside of spec voltage is either by modding the BIOS, which doesn't work since 10 series because Nvidia encrypted the BIOS going forward from that, or you do a hard mod, which I haven't done. So this is within spec. And I got an email. Didn't know if you heard that. Yeah, so another thing I want to talk about is, I think I've said it myself, and a lot of other people in the overclocking scene will tell you that Pascal, Turing, and Ampere we don't know yet, but Pascal and Turing basically don't scale with voltage. What you've seen here is that it's not really true, but I think that my card is an extreme example. So I have no proof for this, but I have a theory for why my card is gaining so much from this little voltage, because it's just 0.043 volts. That's not a lot. Why it's gaining this much, I think, is because my card, my specific core, has a very low ASIC quality and therefore very high leakage. So that means pretty much is it sucks with low voltage and it goes really, really fast with high voltage. Like I think since 10th gen, you can't look it up anymore. In TechPower GPU-Z, you could look at your ASIC quality before, but you see it's no longer in this list, and it isn't for 10th gen also. I think 900 series and older still work. And for half AMD cards, I actually don't know. I know Polaris cards work. But for Nvidia, 10, 20, and probably also 30 series do not show you the ASIC quality anymore. So you technically have to find out by just overclocking it and seeing where it ends up. And since Nvidia cards run at a pretty low voltage, unless you do this trick, while like 1.1 volts, this is basically 1.1 volts. I would describe it as, kinda beginning to be, it's not super high, but it's definitely it's a decent voltage to run at, and not like, and yeah, like usually you get 1.05, and then if you have it under load for a while, it just goes down to like straight 1 volt, which is, that's stock voltage, and I hate stock voltage. I'm an extreme overclocker. I hate stock voltage. So but so because I suspect my core has very low ASIC quality or very high leakage, that basically means like GPU-Z will tell you if you have the ASIC quality tab. Low ASIC quality on air and water means worse overclocking, and on chilled water and liquid nitrogen or dry ice it means better overclocking. And what it assumes is that you run your air and water on stock voltage, or like within the offset that you can set on older cards. And then on chilled water or liquid nitrogen, you oftentimes do go to a lot higher voltage than before. And that's kind of the thing that I've seen. I've also seen it on Polaris cards. I think Bullseye once talked about this, how on Polaris cards like RX 480, RX 580, and all the other cards that are based on this architecture, you want a low ASIC quality for overclocking, because that means they scale a lot with voltage. The high ASIC quality ones, yes, they might hit a higher clock on stock, but they will basically not scale with voltage anywhere as good as the low ASIC quality ones. So I'm just assuming the same goes for Nvidia ASIC quality, and that my core has a pretty low one, which means at stock voltage the clocks are pretty disappointing. But now where I've forced a higher power state and given it just a tiny bit more voltage, it's now reaching actually pretty decent clock. It's nowhere near golden, but over 2100 constant is what I would describe as pretty good. So, if you wanna try this, you can. Like, there's practically no danger for the graphics card. You just force the boost algorithm to give you a max power state. If it hits the power limit, it's still gonna throttle down. If it hits the temperature limit, it's still gonna throttle down. It's just when it's within these boundaries, it will go to the max power state. The only thing is I'm idle right now and I'm consuming basically 90 watts. So yeah, because it's running max voltage and max clock, even though I'm not doing anything, which means, yeah, 90 watts at idle, which is far from ideal. So if you want to try this, if you're an overclocking enthusiast, I would suggest you definitely try this. But keep in mind that the power consumption in idle will be through the roof. So if you idle your system a lot, maybe don't do it. If you game most of the time or have the GPU under load most of the time, it won't really make much of a difference. But if you have your system sitting around, like turned on but not really doing anything, you're going to waste a lot of power doing this. But I most of the time game, so yeah, I'm fine with this. And also I have an Intel CPU which is overclocked to 5.1 GHz, so this is wasting even more power. But yeah, this is a very nice trick, and I'm actually kinda fascinated that I didn't know about this. Like, being able to force it to a higher voltage, because like, damn, it does pick up some serious speed. I'm gonna ask my friends to try this. Like, I have one friend with a 2080, one friend with a 1080, and then another friend with a 1070. And also one with a 2070, but I don't think she's gonna do it. Yeah, it should work on all these cards, because the boost curve is on 10, 20, and 30 series. I actually don't know, does 900 series have a boost curve? I don't think so. Like, it does have GPU boost, but a very basic implementation of it. But yeah, recording this straight from my desktop, I can't see how long the recording is by now. I would think it is around 20 minutes again, but yeah. So this is a pretty nice trick, and I'm gonna keep this seeing above 21 megahertz and even topping 2100 with like 2130, 2115. That's a pretty nice thing to see. And yeah, like these are some clocks that are worthy of the kind of graphics card it is. So yeah, I hope you enjoyed. Thank you for watching, and until next time, goodbye.